Hey guys, today we're going to look at additional factors that affect climate. This one is planetary. It's known as ENSO, or El Nino Southern Oscillation. It's a phenomenon that periodically occurs in the tropical East Pacific, where we see a shifting wind pattern that causes a change in the ocean surface temperature. These phenomena can cause global changes in rainfall, wind, and ocean circulation patterns. So let's take a look at it. Off the coast of South America, off the coast of Chile and Ecuador and Peru, in the tropical East Pacific, the fishing is amazing. Chilean sea bass, so good. And the reason why the fishing's so good there is because the winds typically blow from east to west. So it blows off the continent of South America towards the Pacific Ocean. What that does is it actually pushes warm surface water away from the coast. This sets up an upwelling. So let's go ahead and define that. An upwelling is the upward movement of cold, nutrient-rich water to the surface of the ocean. All of these nutrients that get pushed up here in these upwelling events provide the basis for the marine food system. In fact, the food web off the coast is absolutely amazing and complex. And all of these nutrients from the upwelling support a thriving fishery. What was noticed, though, however, right around Christmas time, every few years, the fish stocks plummeted. And the fishermen didn't know why. And so they ended up calling this event El Nino. And so El Nino, we know, means the child, but capitalized, this is a biblical reference referring to the Christ child because it happened around Christmas time. And the fishermen didn't know what to do, right? All of their fishing gear, they checked all the nets to make sure there weren't holes in it, but they couldn't explain why the fishing stocks plummeted every so often. That's because this upwelling event, where nutrients were brought up to the surface, cold nutrient-rich water, stopped, and they couldn't explain why. So let's look at what's going on. Here are the normal conditions. This is what is typical in the tropical East Pacific. We have easterly winds blowing from the coast of South America to the west. It's pushing warm surface water away. Notice we have what we call a thermocline. This is a profile of the ocean. And a thermocline can be defined as a boundary between warm surface water and cold deep water. So as these winds, easterly winds, push the warm water away, the cold water rises to the surface in an upwelling to fill the void. That's what creates the normal amazing fishing conditions, as all of the nutrients deep from the bottom of the ocean, from our major carbon sink, rise to the surface to stimulate productivity. So all of these winds blowing off to the east push all that warm water way off in the tropical West Pacific. That creates a warm water condition way over here by Australia, and where there's loads of evaporation, warm water, and atmospheric moisture creates a low pressure. This warm, moist, rising air expands and cools, and it sinks, and it sets up this sort of self-perpetuating loop that sustains these typical easterly winds. During El Nino years, every few years, however, this whole thing reverses. The easterly winds weaken, and they die down and actually reverse. And now we have westerly winds. These westerly winds push back. And they're pushing that warm water and sloshing it along the west coast of South America. That puts a lid on the upwelling. Now we have warm water suppressing that cold, nutrient-rich water, which would normally rise along the coast. Now we have cold water sitting off the coast, excuse me, warm water sitting off the coast of South America. This warm bath water generates a lot of evaporation. This seeds the clouds, and it completely disrupts atmospheric conditions, not only for South America, where they experience intense flooding and rainfall, but up to 2/3 of the global climate. So this is like a lot like throwing a stone in a placid pond that has a rippling effect. Hurricanes, for example, in the Atlantic Ocean mellow out. We experience oftentimes large snowfall during these El Nino events. Large flooding and mudslides happen in California. So depending on where you are, oftentimes you experience more precipitation or less precipitation. Oftentimes global temperatures increase during these El Nino events. All of these changing phenomena return back to normal during what we call a La Nina, and that's a return to normalcy, where the easterly winds actually strengthen, further pushing that warm water away from the coast. The exact reasons why these cyclical events occur every 3 or so years is not fully understood, but it's highly variable. So one El Nino event compared to another is very different. So this is yet another factor that controls global climate and certainly influences the distribution of life. That's it, guys. We'll see you soon.